Anyway, solve compound inequalities, graph the compound solutions and write them in interval notation, use of and or statements in the inequalities. So that's what we should be able to do by the end of this lesson. So let's go ahead and start the first part, and that would be the what we need to know. So the steps that, well, I should probably change this from steps to use to things you need to know. That sounds a little bit more better. I mean, like if we're talking about equations or something new, it would make sense to say that instead. But anyway, so the first thing you're gonna have to put on there is compound inequalities. So what is a compound inequality? So compound, as you might know, means many, like a bug, say a fly, has a compound eye, which if you look really closely at it, it's a whole bunch of eyeballs kind of bundled together. So that's compound, it means many, and inequalities means, well, inequalities. So many inequalities is what it means, but here's the definition that I want you to put on your paper, and that is two or more inequalities graphed together on the same number line. So there are two types. And again, those are the or and statements. So let's look at this number line we have right here. On this number line, I have solutions from negative infinity all the way to -4, including -4. So again, x values less than or equal to -4. But then we have a second line over here. The second line says that we have to have an x value greater than 1. Now, in this case, I can choose one or the other. So it's kind of like if you're at the lunch line, you might get a choice of something like hamburger or pizza, right? You can only pick one of those items. Or if you are choosing something like say you go to, I'm trying to think, I know I saw this a while back, but like if you're going to apply for a job or something, they might say you need some kind of ID, and they'll give you a big list of them. They might say a driver's license or a state ID card. Sometimes they'll even take student ID cards, something with your picture on it, really. So, you know, those are or statements. They want one of those or the other. So to put it in interval notation, it's kind of what I said before. So from negative infinity up to and including -4. Then we have this U symbol that is union. And we have a disjoint set. So it starts again. So we have nothing in between here. And it goes to 1, but not including 1, all the way to positive infinity. So in other words, we have this area in the middle that does not have solutions in it. So to solve the inequalities, the or inequalities, make sure you solve each part and then graph both of them on a number line. And then we have to show the solutions. So there you go. That's the first part. Let's go ahead and get right into working on some of these problems. One of the first things I like to do, and this is just me, I like to put a little line right here, because I know sometimes it looks confusing when you have a lot of stuff and you want to keep this stuff separate from that stuff. But just like we did yesterday with inequalities, just work on them like you would ordinary algebra equations. So I'm going to go ahead and -4 from both sides. So leaves me with 3x is less than 6. And now we continue to try to get that all the way by itself. X is less than 2. And there's our first part. That's the first solution that we have. And again, we're going to have 2 of them on most of these, or about half of them. So I'm going to mark out -2 with my line. And I need to find out which way it goes. So if you remember, we're going to do the same thing from yesterday. Best method of doing this is to pick a number. So it says here x is less than 2. So my guess is that if we want to look for the numbers that are less than 2, we got to go this way. And if I check it, let's say -6. -6 is less than or equal to 2, which is true. That means that this is pointing in the correct direction. Remember, all these numbers under here should be the solution. All right, so let's go ahead and work on this side. This one's another kind of easy-ish one. We only have one step to do for this one, and that is to divide both sides by 5. X is greater than 9. So mark out 9. I'm going to need an open circle for this one because we are not including that in the solution. So 9 is not included. It has to be higher than 9. So it's got to go this way. And I'm gonna prove this one false. Let's try 2. 2 is greater than 9. Okay, so it's false, and it's not under the line, so it should be false. So 2 would, well, in this case, 2 would work with neither of these. And I noticed that I picked -2 instead of 2. There you go. Make sure I pick the right one. And I'm going to go ahead and make a statement here. So write it in the statement. So x less than or equal to 2 or x greater than 9. So x has to be either less than or equal to 2 or greater than 9. As long as it works, as long as x is in one of those groups, it should work out as a solution. Let's go ahead and put it in interval notation. So interval notation, start from the left and work your way right. So we get to 2 bracket because it is included. And then we use that U symbol. And we have the hollow circle, which means it's not included. So we have 9 not included and 9 on to infinity. There we go. So that's it for number 1. Move into number 2. Again, I'm going to put a line here just so it's a little bit easier to see what's going on. I'm going to -6 from both sides. Nothing too out of the ordinary. Hey, wait a minute. If I subtract, do I have to flip the sign? So remember what I said yesterday. If you add or subtract, you never flip the sign if you add or subtract, because adding and subtracting will always keep it true. So that was an easy one. Make sure I get the right negative number this time. So -1. And this one is included, so I'm going to use a closed circle. And this says that n is less than -1. So I need n values less than -1. Let me make that line a little bit straighter. And again, let's check it. So let's pick -4 since my mouse is right there. -4 is less than -1. And that's true because if you have 2 negatives, you want the one that is less negative. All right, so that takes care of the first one. Looks like with this one, we're going to have 2 steps. So -7 from both sides. 9n greater than, and let's see, 43 minus 7. Okay, and we still got to get that n by itself. So let's divide both sides by 9. And n is greater than 4 is the way we would read that. N is greater than 4. So open circle, because we're not including 4, but everything greater than 4. And write the OR statement for our number. So n is either less than -1 or it is greater than 4. So again, you have a bit of a choice. You have to pick either one of these or the other one. Now let's put in an interval notation. So -infinity. And going right, we run into -1, so it stops at -1 and is included in -1. So I'm going to go ahead and put a bracket there to show that it is included. 4 is not included, so I'm going to use a parenthesis. So from 4 to infinity. There we go. Okay, not bad. Some kind of easier problems, but that's to get you the idea on how to do these. And again, it's the same thing as yesterday, but the only thing that's different from yesterday is that we're doing pretty much 2 inequalities for every problem. All right, and as usual, they're gonna turn the difficulty up on us a little bit. And I'm going to start working on this problem here. I need to get that y by itself, so -8 from both sides. -3y, and 8's gonna cancel out, so I'm not gonna get to my next step. -7 and -8 is -15. And now I have to, wait for it, divide by -3. Now again, this is something you should be looking for. This is something that immediately should jump out at you, because anytime you use a negative in multiplication or division, you flip it. So it's open here to the right. When I flip it, it should open to the left. So make sure you switch your sign on that. Negative divided by negative is positive, and 15 divided by 3 is 5. And it leaves me with just y. And y is greater than or equal to 5. So I'm going to mark it with a closed circle to show that it is included in the solution. And I want numbers greater than 5, which if I pick 8, 8 is greater than 5. The mouth is open towards the bigger number. So we know that is the solution for that one. Let's move on to this one here. I'm going to add 3 to both sides. And I get 10y is less than or equal to -30. All right, now we got to get rid of this 10. So divide both sides by 10, because that is 10 times y. Do the inverse. Y is less than. Now, do I need to flip this one because I'm dividing with a negative number? No, only when it's the bottom number. When you're using that number to divide and it is negative, that's the only time you flip the sign. In this case, just because I have a negative and it's being divided doesn't mean that we flip it. Only when your bottom number, when you're dividing, or if you multiply the whole thing by a negative. And in this case, we get y. Y is less than -3. So mark out -3. It looks like I'm going to have to use another filled circle on this one. And I'm going to have to make it go this way here to the lower numbers, because y is less than -3. And again, that's how you read it. Read it from left to right. Y less than -3. So if I'm looking, like if this is hide and seek, and that's my clue, y is somewhere less than -3, then that means I got to go this way to find it. All right, now to put it in interval notation. So let's see if we can do this. So -infinity, because we're starting from the left, and it stops here and kind of ends at 3, or I'm sorry, -3. But it is included, so I'm going to put the bracket on there. Use the U symbol for union. And let's see, I got to do this side. So it's going to be y values greater than 5. So greater than 5, including 5, all the way to infinity. But we can't include infinity, so it's going to still be a rounded bracket for that one. I'm sorry, a rounded parenthesis for that one. And there you go. See, not so bad. It's like, again, the same thing we did yesterday. So if you're pretty good at doing fractions, I mean, not fractions. I was looking at this next one. There is a fraction in there. But if you're pretty good at doing inequalities, then this is no problem. But this fraction here, that might be a problem. Okay. Go ahead and split our workspace. Oh, you know what? We didn't put this thing in the OR statement, so let me go ahead and do that. So again, y is greater than 5, or y is less than -3, including those numbers too. I just need to put an OR there. I almost forgot that. All right, so let's go ahead and get this 6 out of here. Divide both sides by -6. So this is -2a. Looks like it's less than 2. got to get that 2 out of here. And there we go again. This is the part you have to worry about. It's one of those things that if you're not looking for it, you can easily forget it. All right, and I think I forgot some of those in my morning classes as well. I was like, I spaced one out and did not look for it. But luckily, one of my students who is vigilant caught it and said, hey, you got the wrong one. I was like, oh, okay. I told him you don't need to worry about that. Everybody makes mistakes. Nobody's perfect. Now, I just got done saying that's the part you need to worry about, right? So again, anybody can miss it. So watch out for that. A in this case is supposed to be greater than -1. You got to flip it, come up with a process so that way you don't forget to flip it. As soon as you see this part, usually what I do is I write it. So if you remember what I did with this one, as soon as I put the -3, I flip the sign. That way I wouldn't forget to flip it later. So that's just, I guess, a process you can use to kind of catch yourself before you forget. All right, so a over 2 and -3. There you go. So combine -2, -1, you get -3. And I want to get rid of this 2. So remember that this, if you're not sure what to do, check out what's happening to it. A divided by 2. So we need the inverse of divide by 2, which is multiply by 2. So I'm going to multiply both sides by 2 to get rid of it. And again, this negative has nothing to do with it. It's only the numbers you're using. So I'm multiplying both sides by a positive, so I don't need to switch the sign. And it looks like I'll be able to solve it after this. So A equals, I'm sorry, not equals, A is less than -6. So let's go ahead and mark those down on our graph. I'm going to make a bigger circle so you can tell it's an open circle toward the negative. And it looks like we have one on 1 as well, so they're both negative. So open circle on -1. Make sure I have it on the right one this time. All the way over here. And let's use our graph to put it in interval notation. So from -infinity, it goes to -6 and stops there, but doesn't include -6. Union -1 on to infinity. Okay, that looks like a pair of glasses. Let me fix that. There we go. And that's it for this one. Looks like we're making some pretty good time on this. I hope I'm not going too fast. But again, you should have the packets hopefully by now. If you don't have the packets, Schoology is working. I got everything just about uploaded to it. So you should be able to log on to Schoology and download your assignment. So even if you're working with, I'm not sure how you can get it, but if you have a printer, you can print it out. Or you can do what I'm doing and just sort of cut and paste things and draw on it. Although I know that's not a very ideal solution. It is what it is. But anyway, yeah, I did have some students saying that I don't have the assignments. Can you just email them to me? So that's the way to fix that, is that now you can go on to Schoology, look for your classes and see what's there. Okay, now let's get this solved. So first thing I did was distribute that 3 to both of them. And make sure that when you do that, you double check your work. So 3 times 2 would be 6. Okay, that would be bad. Minus 15. I ate lunch here today. I didn't go anywhere for lunch. Okay, get this -6 off of there. And like I said, best thing to do, change your sign. I see that there's a negative here. So before I do anything else, I'm going to change my sign. So flip it. K greater than 4.5. So I just divided 27 by 6. And that gives us 4.5. So let's go ahead and graph this part. So mark out 4.5, which is, well, here's 5 right here. So 4.5 is going to be like right between 4 and 5. Open circle. And again, K is greater. So if I'm looking for the K, I got to go this way. Now here we have something a little bit different. We have a fraction, but this is a particular type of fraction where there is a 1 on top. Anytime you have a 1 on top fraction, basically it means divide. So what I mean by that is 1 over 3 times 15. And again, I'm going to put 15 over 1 because 15 divided by 1 is, well, still 15. It's not going to change anything. And 1/3, right? Multiply top number to top number, you get 15 over 3. So it's just like dividing. 15 over 3 is going to be 5. Now again, that's just something to remember. If you see a fraction like that, multiplying, it actually means divide. So let's go ahead and use that. 1/3 of 9 is the way you would say that. Take 1/3 of 9, so take 9 and split it into 3 even groups, or 1/3 of it. That would be, I said 3 even groups. I mean, I said it, but I don't know why it didn't go through. There we go. Okay, now we can get to getting that K by itself, the other K. Add 3 to both sides, and I get K is less than or equal to, okay, so let's see, 3 minus 3 is 0. Does this mean we have no solution? No, we still have a solution because we still have the variable. K is still there. Since K is still there, it is a solution. This just means that it's going to be greater than 4.5 or less than or equal to 0. Because if I divide both sides by 5, right, so 5K, divide them both by 5, 0 divided by 5 is still going to be 0. All right, if you had 0 Skittles and 5 people, you still have no Skittles. Okay, for this one, I'm going to need a filled circle at 0. And again, I'm looking for numbers less than 0, so that means I got to go this way. And now time for interval notation. So from -infinity, we get to 0, which is included. So I'm going to use the square bracket. Union. The next one we reach is 4.5, which is not included, so use a parenthesis. And it goes to infinity, like that. All right, now on to number 6. So again, I have 2 different equations. I'm gonna have to get rid of this -3 before I do anything else. I hope I don't run out of space. So I'm just gonna do this to show that I'm multiplying this and this by -3. And that's gonna get rid of my bottom fraction because -3 divided by -3 is going to cancel that. Now, remember the rule, it is multiply or divide both sides by a negative. I timesed both sides by a negative. So again, just so I don't forget, first thing I'm going to do is flip the sign. There you go, flip the sign. And then I'm going to continue writing everything else. And this side, I'm going to have to multiply. So -3 times -5. So that would actually be positive 15. And there we go. So again, flip that sign. Now I got to get this x by itself. So I'm going to get rid of the 8. So -8 on both sides. Negative x is greater than or equal to 7. And it looks like I'm going to have to divide both sides by -1, which again means I am going to have to flip this sign again. And I like these worksheets. They're pretty good because they keep you on your toes. A little bit of a challenge because this is the very first time I've ever seen an assignment that made me flip the sign twice. So we kind of ended up right back where we were. I don't think there would have been an easy way to do that, but it is what it is. All right, -7, so let's go to -7, and it is included because we have the or equal to, so closed circle, and it's less than -7. All right, now let's work on the other side. Looks like we're gonna have another fraction. I'm gonna, let's see, I'm gonna get rid of this 5, so -5 on both sides. And remember, you gotta keep it on both sides of this thing. On occasion, I will see a student minusing 5 twice from the same side. No, that's not the property of equality. You gotta do it to both sides. Although that's not as common. And if it is common, it usually happens more in lower level math courses. But it is one of those things you gotta watch out for. Now, for this one here, I'm gonna do a special trick. I'm not sure if you remember from quite a while ago. I don't remember exactly which lesson. It might have been solving radicals that we had earlier. But one of the tricks I showed you is to multiply both sides because I got to get rid of this fraction. I got to multiply both sides by their reciprocal. You can do it one at a time. So you can say divide both sides by 2 and then, wait, okay, hold on. You would multiply both sides by 2 and then divide both sides by 3, but I'm going to go ahead and do both of those things at once. Now, I also have to get rid of this negative as well. Okay, so don't lose track of your negatives. That's something that it can happen to anybody. Anybody can do that. So negative times negative is positive. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1 or x, right? Because 1 times x is just still going to be x. Now, I'm going to go ahead and multiply this side, put a 1 under it. 6 times 2 is 12. 12 divided by 3 is 4. And I hope you caught it, because I said that you were supposed to switch this, and I even marked it in red. And that's why I tell you guys, make sure that when you do this, write the sign down as soon as you say, oh, wait a minute, it's one of those things I was told about. So make sure you switch that sign. Very easy to forget. Now x is going to be greater than 4, so it's not included, open circle. And x is greater than 4, so I need to find the numbers that are greater than 4, which is this side. Now we just have to find the number. So starting from the negative infinity, we got to work our way to the right. So starting from negative infinity, we stop at -7, which is part of the solution. It is included, so we're going to use a bracket. Union, and starts again at 4, but doesn't include 4, and continues to positive infinity. Okay, and that's it for the OR statements. Remember, I told you there are 2 cases. So we're going to start with the AND statements. So this is just the exact same page, but the backside. So AND statements look like this. So an and statement, thinking about it, if I told you, in order to get this job, so there's a job listing and it says you need a valid driver's license and a social security card, right? You need both of those things. If you go to the job interview and you only have one of those things, you will probably not get the job. You need both of those things. If you want to go on the school field trip, just hypothetically, there is no school field trip, you need $15 and your parents' permission form. Something like that. You need both of those things. So in this case here, I have a graph. So this x is greater or equal to -2, and it is less than 5. So x is greater than -2, and the x is less than 5, but not including 5. And then to put it in interval notation, so again, -2 is included, so we use the bracket. And it goes on to 5, but not including 5. So we use the parenthesis. Now, whereas the other one, we're pointing away from each other, like I was telling you, do you want pizza or hamburger? Right? You have to choose one. But what if I said pizza and hamburger? So that would mean you get both of them. So it has to be a solution for both of these. There is another way we could write it. With an and statement, okay, so we have the exact same thing as up here. Right? X is greater than -2 and x is less than 5. So we could cut out the and statement. So what I'm going to do, and I'm going to do this in plenty of examples because I don't know if it'll make sense the first time I explain it, but it'll make more sense once you get to use it. So we're going to take that x is greater or equal to -2, and I'm going to flip it. I'm going to rotate everything, including the direction of the opening for the inequality. So again, it's open towards the x and away from the -2. Rewrite it. Away from the -2 and still open towards the x. Once I flip one of them, I combine the other one on there. So now it's all one statement. And this is what we call a between statement. So we say x is between -2 and 5. So there you go. That's a between statement. And one good example is like, well, it's kind of harder to find them nowadays, but like, certain carnival rides, they will say you need to be at least 4 feet to ride. But then sometimes they'll have an upper limit, like they'll say you can't be taller than 8 feet, which is almost nobody. Very few people are taller than that. So they almost never mention that. But if you tried to get on the zipper and you were 8 feet tall, like if you were Yao Ming and you tried to get on the zipper, they'd probably tell you no. So there's plenty of in-between statements in real life. And they're pretty common. So what you got to do is solve each part separately. If they are condensed, which means they are already together, it says here you can solve it all together and work inside out. But I'm going to show you a different way. I'm going to show you the way I was taught. I don't know if it's going to be easier, better, faster, or anything, but to me, it makes sense to me. So let's go ahead and start solving some of these. -3 from both sides. So what I have here is 2x greater than, put these two together, so I got -12, -9 and -3 is -12. And now I have to divide both sides by 2. So divide both sides by 2. And I have now x is greater than -6. So mark out -6, open circle, because it's not included. There's no or equal to. It's just greater than. And I'm going to mark a little tiny arrow. Okay, check it if you're not sure. If I pick positive 2, 2 is greater than negative 6. That's true. All right, positive numbers are always greater than negative numbers. So I think that's it for that one. Let's go ahead and move over to the next one. I'm going to get rid of this 2 here, so add 2 to both sides. And now I have 8x is less than 32. So what number can I times by 8 so that it's less than 32? Well, let's keep solving it. Divide both sides by 8, because again, that's 8 times x. So it has to be a number less than 4. If I multiply 8 times any number less than 4, I should get less than 32. But again, the solution, this part here we're looking for, says x less than 4. So I'm going to go ahead and put another open circle here. And again, x is less than 4. So I got to go looking for the less direction, or check it. 0 is always less than positive numbers. So 0 is less than 4. That's true. If someone gave you a choice between getting $0 or winning $4, you would probably choose to win $4 rather than $0. Well, they might tell you, you know, you tried very hard, but you're a winner at heart, but you don't get the $4. Anyway, let's take this number, start with your smallest one. Okay, start with your smaller number. So in this case, I'm sorry, your less number, your lesser number, which in this case is negative 6. So same thing, go left to right. Going left to right, we start with negative 6, and the mouth is open towards the x. Opening towards the x. When I flip it, that x should still have the mouth opening towards it. Now take that take that x less than 4 and move it right here so that x and x are shared, x less than 4. And that's the way we write this. We could also put an and statement in here. So we could say x is greater than negative 6 and x is less than 4. But a between statement makes a little bit more sense. In order to be true, x has to be more than 6, but less than 4. Okay, if it's anywhere in between here, that is a solution. Like if I pick 2, 2 is greater than negative 6, but is less than 4. So it fulfills both of those requirements. It is greater than negative 6, and it is less than 4. So write it out in interval notation. We're not including, oh, wait a minute. We don't have a negative infinity in this one because, well, look at it. There's nothing over here. The smallest number we have is negative 6. Largest number is 4, and we have nothing after either of those. So at least the interval notation on these is a little bit easier. We don't have to include the infinities, whether it's negative or positive, right? So we don't have to include those. It's a lot easier because I only have one set because everything is between those two numbers. All right, continuing, let's go ahead and minus 1 from both sides. 2w 10. So what number can I times by 2 to get it less than or equal to 10? Divide both sides by 2 because I just need to get that 2 off. And w less than 5. So again, mark out your numbers less than 5. Filled circle because we are including 5. And numbers less than 5. So I'm going to go this way. It looks like I'm going to have to go that way. Make that arrow just a little bit nicer looking. There you go. And I don't know where it's going to end, so I'm just going to just do a little bit. Okay, just do a little line there. And now we should solve the other equation that goes with it, because again, each of these has 2 equations. So minus 1 from both sides again. Negative 5w less than 40. So what number can I multiply by negative 5 so that it's under 40? Keep going, divide both sides by negative 5. W, oh, wait a minute. We divided by a negative. Okay, it's really easy to miss those. So in this case here, W is greater than negative 8. So I'm going to go ahead and mark out negative 8 with an open circle because we don't include it. And now I'm going to make this line go all the way to the other side. There you go. So everything under this line is the solution. Now you might be asking, well, what about something like, say, positive 8? Well, if I plug in positive 8 for W, that would make it false. But if I plug it into this one, 8 is greater than negative 8, that is true. But again, because of the AND statement, you need both of them to be true. Okay? You need both of those things to be true. You know, like I was just saying, with like you need an ID and a social security card or something like that. You need both of those things in order to meet the requirements. So let's go ahead and I'm going to rewrite it into a between statement. So start with your smaller number. So in this case, my smaller number is 8. The mouth is open towards the W, so flip it. That whole thing is flipped now. So it means the same thing. Again, if you have an older brother, your older brother is always going to be older than you. All right, you could say my older brother is older than me. Or I could also say I am younger than my older brother. Both of those are true. So in that case, the older brother is still always going to be older. So if I flip it, if I say W is greater than negative 8, negative 8 is less than W, it's the same thing. So again, make sure you flip the whole thing. Everything flips. Now grab your other number and drop it in there. So W is shared so that it's less than 5. There we go. Now we have our numbers. So starting from the left and working our way right, the smallest number we have is 8, but it's not included. And it goes all the way to 5, which is included in the solution. So there we go. That is the answer in interval notation. And again, it always starts with the smaller number. And this is our between statement, which, yeah, let's just put those on there, you know, just to practice writing it. Okay. Not bad. So these are what we called, I forget what they called them. What was the thing that they condensed? I was about to say conjoined. I guess that would also be true as well. But here they put them together already. So if you were in my in-person class, I would usually cover one side of the board or one side of the inequality with one number and then write it and then cover the other side and then write that. But I'm going to try something a little bit different. Since I have colors, I'm going to color code it. So I need to include one inequality. So look for the other one. So I'm going to circle this set here. Hopefully the colors will make it a little bit easier to notice. Now I'm going to go to the other inequality, which is between A and this one here. So that's the other inequality. Circle this on this side. So now I have two inequalities. So I'm going to write them both down. And again, if you read the directions, it says you can do them both at once. But I think this way is less confusing. Maybe it's not as fast. It's probably about the same accuracy in getting the answer. So I have two equations. I have one in the orange and one in the green. From here, we just continue solving like we normally would. Let's see, -2 plus 1 is, I think, -1, less than A. And it looks like that one is solved. We could probably graph this one. And I mentioned something about shortcuts earlier and how you should never use those shortcuts. Okay, so if I were to mark out -1 here, some people will say, ooh, it's telling me to point this way. Well, if I check it, which again, I say you should always check it and never use this shortcut. It worked, okay, it worked at a time. It works 9 out of 10 times. And there is a reason why teachers teach it, because it's fast. But once you know it, you have to learn more about it, okay? So like if you have a job, you might learn something easy first, but later on you learn better ways to do it. Like working a fry machine or something, there's ways you can speed those things up. But let's check it. So if I put in -4, it would say -1 is less than -4, which is not true. The mouth would be, oh wait, it is true, or is it not true? Well, okay, so let's plug something in. Let's plug something we know for a fact is true. Let's plug in 2. -1 is less than 2. That's true. Negative numbers are always less than positive numbers. So it means it has to go this way. So again, don't rely on those shortcuts. You are going to confuse yourself, and you will probably get wrong answers quite often. A is less than 7. And there you go, mark out 7 with a filled circle. And now I gotta find out which way to go. So A is less than 7, so again, test it out. 4, so 4 is less than 7, that is true. So everything between here and there is a solution. And let's go ahead and mark it in interval notation. So smaller number goes first, -1, and it is included in the solution, so use a bracket. On to 7, which is also included in the solution, so bracket also. And that's it for that one. But again, the main thing that you gotta take away from that one is to break it into 2 separate equations. And again, there is a way to do it like 3 at a time, and that would be something like -4, -4, -4. But that way is a little bit confusing, and again, this is the way I learned it, and that's the way I'm gonna teach it, unless it's obviously proven to be like superior in every single way. I'm just gonna circle both of them. And again, you circle it right up to before the inequality, don't include it. And that's your first group, and their second group is gonna be, again, right up to the inequality, and then everything after that. I'm gonna write out my inequalities. And then I'm gonna write out the one in green, so 3p plus 4 less than 19. And then again from here, we're just gonna use our inverse operations. It looks like I'm gonna end up with a 0 here, which is okay. I don't think that's gonna affect anything. If I divide both sides by 3, I get 0 is less than p. Okay, so that's it for that one. Let's go ahead and do this side now. Looks like we're gonna have to do some of the same things. Looks like I'm gonna have to -4. So -4 from both sides. And I get 3p less than 15. And that's gonna, I'm gonna have to divide both, oopsie. What happened there? Okay. Divide both sides by 3. I should have wrote that in green. I was trying to switch it over to green. Cancel that out, and p is less than 5. So there you go. I wrote it into the and in between notation right off the bat. Okay, so with a little bit of practice, you can do it pretty easily. That way I don't have to rewrite the whole thing. And there you go. So p is between 0 and 5. So 0 and 5. Combine the 2 lines together. There we go. last thing is interval notation. So interval notation, so again, from 0 to 5, not including either 0 or 5, so parentheses on both sides. All right. Now this one seems to be moving a little bit faster than my other classes. Hope I'm not going too fast. But like I said, if you have the packet in front of you, you know, it saves you from having to write the problems out. So that's gonna save you a little bit of time. And Schoology is working too. So if you want to download these and write them down before we start, that works too. Which reminds me, I need to grade some of the submitted assignments that were submitted online. Okay, so same thing. Let's go ahead and break this down into two parts. Boop. And that's my first group. So again, right up to the inequality. Here, same thing. Go to the inequality and everything over here to that one. And again, usually I would show students and tell them, okay, cover up this side, write it out. Cover up the other side, write it out. And it seemed to work pretty well. I don't think I had very many issues with that. So let's write them out. 28 greater than negative 2 minus 10m and negative 2 minus 10m greater than negative 7. Okay, so I got to get working on this m to get it by itself. So it looks like I'm going to have to add 2 to both sides. Plus 2 here, plus 2 there. So I get 30 greater than negative 10m. So I need to get that negative 10 off of there. So divide both sides by negative 10. You got that? Divide by a negative, so I got to flip the sign. So it was opening towards the left. Now when I flip it, it's opening towards the right. So that's going to be 30 divided by negative 10, which is going to be negative 3. Let me write that a little bit higher. Negative 3. And negative 3 is less than m. So let's mark out negative 3. And it's less than m. So which way does it go on this one? Now I'm going to pick 0. 0 is a good one to pick because 0 is always greater than negative numbers and is always less than positive numbers. So if you have a negative and you have 0 and your mouth is, the mouth of the inequality is open towards the m, then that's true. So in this case, it's going to be true. So it's going to go this way. All right. So again, check a point, pick a point, test it, see if it works. That is the best way to check it. That is the best way to determine which way it's going to go. All right. So I almost forgot the m here. So I just sort of stuffed it in there really quick. Okay, and we get negative 10 m greater than, in this case here, it looks like we're going to have negative 5. And, you know, we haven't seen any fractions in this one in a while. Well, I think we did have that 4.5, but this one looks like it could be another pretty good fraction. So divide both sides by negative 10. And again, as soon as you notice that, let's put the sign, the switch on the sign. So now I switch the sign. M is still on this side, and here I have 1/2. Now I made a little bit of a mistake here. I was too focused on trying to switch the sign, and I accidentally divided both sides by m. that would cancel the m and move to the other side, which we don't want. But that was a small mistake, had very little impact on anything. So moving over here, so I have m is less than 1/2, so mark out 1/2. So 1 is right here. So 1/2 is between 0 and 1, and we're going to mark it here. And we just need to join the sets together, put it in interval notation. So from the smaller number, which is -3, on to 1/2. And it doesn't look, oh wait, sorry. We're going to have to use a bracket here because of the or equal to. I must put a parenthesis there. This one does not include -3 in the solution, so I'm going to put a parenthesis there to show that it is not part of the solution. Now, we still got one more small step to do, and that is to join the set so that we make it as an in-between statement. So we're going to treat these, and again, it says write each solution, but we're going to combine both solutions into one. And I don't really have a place I can put this. Maybe I can move this up a little bit, and maybe I put it in here. Nope. Undo that. I just need my blackened pen. So starting with the smaller number, -3, less than m, and then grab the m from here and pretend that it's the same m. Well, I don't need to pretend it is the same m. And there we go. Now it is in an in-between statement. Okay, last question. This one's a fraction one, so it's probably going to be a little bit of a tougher one. I want to get that bottom number. I want to get rid of it. And this one's a bit of a tricky one because I feel like I have to use the trick that they went and told us where you solve all three of them at once. So I'm going to do that. I'm going to times everything by -2. Because I want that fraction gone, I have to times everything by -2. And remember, anytime you multiply or divide by a negative, you gotta flip those signs. Everything flips signs, okay? And I just noticed that I flipped the sign on the first one, but in this case here, this negative is gone on the bottom, but this is -5 times -2, so that should be +5. And this is -2 times -2, which should be +4. All right, it's a good thing I'm checking myself. I made some mistakes on this one on my last class, and I think even the class before that one. So all day I've been messing up this number 12, and it's probably because I'm telling myself, oh man, I'm almost done, almost there. So I get that kind of like relax, when you're working on something and you feel like you're so finished, you're so close to the finish that you just feel like relaxing. I think that's what I had earlier. So make sure I write these. So again, I'm going to write these two here. So I'm not going to circle them just because I already have a lot of stuff going on. So maybe I should have just underlined them from the beginning. Maybe that would have been a little bit easier. Anyway, so I wrote the two equations. Let's go ahead and solve them. So -12 on both sides. And 5 minus 12. Oh, shoot. I was about to say, that doesn't look right. This should be 10 because I doubled everything, and I should have doubled everything, but this should have been 10. Okay, so there you go. That looks a little bit better. 10 minus, that'd be -2. And then it looks like I'm going to have to times everything by -1 or divide both sides by -1, which again, that's going to cause me to flip the sign. And I tried to save as much space as I could, but it looks like I'm going to have to write it over here. So 2 is flipped, so flip that to x. Okay, and on this side here, I'm going to have to -12. And I get -x is greater than -8. And again, I'm gonna have to divide both sides by -1 so that I can get rid of that negative so they cancel out the negatives. And what that's gonna do is it's gonna flip the sign, and I'm gonna use the same X right there. So that's like the same X, it's the same direction, so it makes it really easy. And I can see now that it wants me to put the number between 2 and 8. So mark out 2 and 8. 2 and 8. Make sure you use the right circles. So open circle. Wait, okay, backwards. Okay. And again, it's probably just because I'm trying to hurry through this, which I guess is something a lot of students do whenever they're trying to get done with their homework. They rush through it. All right, and that's just a lesson here that everybody, when you rush them, you just don't have a good, you just don't do a good job when you're rushing things. Anyway, so there we go. So the answer is between 2 and 8, including 8. Or wait, I just barely caught that. You know, I don't know why, but my brain's just not catching this one here. That's like the second time I did that. I put this wrong symbol here, and then I put the wrong circle in there, and now I put the wrong bracket on there. Okay, so like I said, chill a little bit. I need to, all right? I need to, I'm trying to keep this, I'm really paying attention to the time, so that's probably why I'm hurrying through this. But also, this one is a particularly tough one because we had to switch the sign twice, right? So it's not very common that you end up having to switch the sign twice on these, but that's why I like this assignment. I like these assignments because it really keeps you on your toes. You know, this one's trying to bamboozle me. Okay, school's over. See you later.